Worksquare.
All right, confirm you guys can see me as well as hear me. Okay.
Yes, you can. You can.
All right. Thank you so much, Blessing. Okay. Good evening, everyone. Thanks for coming out for this workshop. I promise that it's going to be a very interactive one. So my name is Christian. I'm a software engineer, solutions architect. I currently work with DataMail as a solution architect that helps companies design their backend systems for resilience and also to meet their business objective. All right, so without further ado, let me just go right into it. All right, I'll be sharing my screen in a moment. And also, please, if you have any questions while I'm taking the session, you can always stop me so that I can basically clear you, so that we can have a very, very interactive session. I think we have a small number here, so we should be able to manage it as much as possible. All right, so I'll be sharing my slide now. Please confirm you can see my screen and you can see my slide. All right, please. Okay, thank you, Chris. I need more hands. Kelechi, can you see my screen? Chris, can you see my screen? Okay, I think it was Chris that already showed. What about Mustafa? Yeah, can you see my screen, please? It's like everyone is sleeping. What's going on? Is it a slow Saturday? Please, I need responses.
Yes, I can
Yeah.
see your screen. I can hear you.
Thank you. Thank you so much. Thank you so much. Thank you. All right, so let's get into it. So, good evening again, everyone. My name is Christian. Like I already said, I actually am a solutions architect and I am also a software engineer. I help with building or designing the systems that we work with for our clients at DataMelon. All right, so for this lab, is focusing on building resilient microservices and event-driven systems. I was the one that added on AWS because that is exactly what I'm very familiar with. Right, I can basically give you practical examples right on the AWS side, and it's also another chance for everyone to basically explore cloud. I don't know how many of us are familiar with AWS. If you are familiar with AWS, so if you are not familiar with AWS, I want to see a thumbs up. You are not familiar with AWS, you've never worked with AWS, I want to see a thumbs up. Thumbs up, thumbs up, thumbs up. Let me see. You are not familiar with AWS. Can I say a thumbs up? This is the first time you're going to be seeing anything surrounding AWS. Can I say a thumbs up? Okay, now let me turn it around. If you are familiar with AWS, can I say a thumbs up? Like you've worked with AWS systems before, can I say a thumbs up? Okay. Thank you, Manasseh. Thank you, Chris. All right. So I can see that there are two very attentive people in my class. Thank you very much for that. So what we'll be doing today is basically looking at these systems, the way they work, and then how we can actually apply that, right? So for my background, I'm a AWS certified solutions architect and a solutions engineer at DataMelon. So what I've been able to do for the better part of my career, I first started out as a mobile engineer, working with Flutter, Riverpod, integrating backend systems with REST API, GraphQL, right? So if you know the traditional front-end engineer, they are not always concerned with whatever is going on in the backend. They're always like, just give me API, let me just consume and go, right? So for a long time, that was the tradition. And when I got into tech, doing this for 3 years now, it has always been like that, where you're just basically giving what's it called? Giving docs and you just integrate. But when I picked up my new role at Data Melon, I had to stretch beyond that and started to basically study how backend system works, what makes backend system works, how should you architect a backend system, right? And here we are today, and I'm here taking this lab. So for the agenda, we are already taking the introduction. We'll be talking about microservices. Then we'll be looking at event-driven architectures, then resilience mechanisms. Then we're looking at problem scenarios and how we can solve them, right, architecturally, right? So I'll be drawing architectures right here on the lab, so you can follow along. The tool we'll be using is draw.io, and then you can follow along with your own board if you have it. You can just go to draw.io and you can set up, right? And then we'll do a recap of everything we've learned so far. All right, so you would say, what are microservices? Please confirm you can see my screen. I hope these texts are not too small. I feel like these texts are too small. Please confirm to me if you can see the text on the screen clearly.
Yes, I can see it clearly.
Okay, thank you so much,
Though
Kelechi.
the description are small, but I can still see them clearly.
Okay, please just bear with me. I'd not seen this on the other side. I would have made it bigger. Okay, so if it's too small, please just let me know. I can always quickly adjust it so we can see it more clearly. So we already know that microservices is not the first time we've heard something around microservices. So when we say micro, it means something small, right? Services. So you could put that together and say, okay, small service that does something. At least if you know that much, you basically have some part of the story already to be true. But before microservices, there's something we are comparing with, which is a monolith, right? So you take a monolith as a giant, a bigger system, right? That works together. Everything works hand in hand and they are coupled together. Think of it like, let's take an e-commerce application like Jumia now. If Jumia was a monolith, you have one application running per lifetime. That means whenever you load up your Jumia front end, it's just calling one application, right? The backend system is that same backend system that will do login for you. That same backend system will return product listing. That same backend system will do purchase order. That same backend system will do your payment integration, right? So that's what a monolithic system looks like. You just basically have your UI, your business logic, and your data access layer, right? So what for a microservice is more of a distributed system, right? So you are basically splitting logic per function or per domain, and then you are giving them dedicated resources to run independently. So I don't need to, for example, now, if I'm able to log into a system, a microservice, and for example, the product recommendation microservice is down for any reason, people will still be able to log in, right? Because it's a distributed system. The login microservice is not dependent on the listing microservice or the recommendation like microservice. Everything has their own computer and they run in an isolated network group. Of course, they can communicate with each other using something called like method channels. They can use message queues, or you can even use APIs to call them one from another, right? So, but the major driver for microservice is for you to be able to innovate quickly, deploy independently, and actually have teams segmented to handle specific core business functionalities, right? So if you are following up to this point, can I say thumbs up? Can I see your thumbs up? If you're following up to this point, everything I said up until this time, you understand. Thank you so much, Chris. I saw that. Any other person? What about you, Collins? Are you there? Manasseh, Mustafa. All right, thank you.
Yes, I'm here. I'm finding
All
out.
right. All right. So we have already established what a microservice looks like or should be. So the other part, because remember, it's microservice building resilient systems using microservice and event-driven architectures, right? So what is an event-driven architecture, right? So I had to split the entire definition into different parts. One is the microservice part, the other one is the event-driven architecture. Now, an event-driven architecture is simply something that listens to an event and does something once the event is fulfilled. It's that simple, right? So all this grammar here around asynchronous events to trigger actions, decoupling producers and all of that, it simply means that you have something like a producer, right? That will be emitting events. And you have something called a listener that will be listening for the events. Now, once the producer produces an event and the listener can acknowledge that, okay, this is an event I'm registered with, it does something with it. That is basically what an event, that's the simplest way to describe an event-driven architecture. An example of an application of event-driven architecture is you upload your CV to a CV processor, right? And then the CV processor basically, after your upload, it takes it from the storage and does something with it, right? So that bucket where or the storage location where the assets were dropped can trigger an event, right? It can trigger an event that's okay, something has been dropped, I need you to process it, right? Process the CV, maybe to basically get the skill level of the person or the individual. For example, TribeSquare now can have an application where once you upload your CV, they'll be able to score you, right? Once you score you, you'll be able to know what they can assign you to, right? So that's one of the applications of this event-driven architecture. And there are some other things that inside of it, you have pub and sub, meaning publish and subscribe. You have queues. So queues help you such that if you have a lot of jobs running or you have a lot of things coming up, you don't want any job or anything to be lost. So you can put them in a queue. Once you put them in a queue, it means that whenever the computer is ready or whatever the processor is ready, it can pick it up from the queue and process it and remove it from the queue once it is done, right? So these are some of the things we'll be looking around. Now, let's look at resilience. When you say something is resilient, it means that it doesn't mean that doesn't mean that it won't experience failures. What it simply means that even in the event of failure, it can still function properly, right? Without going down destructively. Now, for example, I log in, right? If it was going to be a monolithic system and I try to log in and for whatever reason any of the services are down in a monolith, once one service is down, it affects every other service, right? The blast radius is the entire application. That's why the entire application can go down, either because of maybe a database error, a network error, or a dependency. Maybe you're trying to call a payment integrator and that payment integrator is down. It can cascade into your system and that can make the whole thing just go down. Now, users just want to log in to check their balance, but the entire thing, they can't actually get access to the application. Everything is down, right? So one of the ways to build resilience is to be able to, is proper error handling, right? Proper error handling and doing something called retries, right? So maybe you try to call a system, it fails, you gracefully handle the error, right? Propagate it back to the user and also retry, depending on what kind of contract or what kind of thing that you are trying to achieve, right? So this actually helps to mitigate against something like network overload, right? And there's also something called circuit breaker. Now, the circuit breaker is a way of cutting off calls to a particular resource that is not already available, right? For example, I'm going to use the payment integrator example. You make a call to a payment integrator, for whatever reason they are down, right? Another system is trying to call that same payment integrator again, is down. Now, at some point, the circuit breaker would just be open or partially open. It will not allow requests to go through. It would basically handle the error or handle the request and then respond some sort of response and say, okay, maybe payment integrator is not available at the moment. But then again, it can then be retrying maybe be pinging the payment integrator, checking the health of the service and say, okay, is it live yet? Is it live yet? Is it live yet? Right? So that's the retry mechanism right there. So you keep retrying until you can get a successful response. Once it gets a successful response, the circuit breaker can then be closed, right? It will close the circuit again, and then requests can go through, right? So please confirm to me that you understand everything I've said up until this point. Can I see a thumbs up? Anybody? Thank you so much, Chris. Thank you so much. All right. So of course, thank you so much, Kelechi. Now, for us to be able to architect or see what's going on in our systems, monitoring is very, very important. And that is why, apart from the circuit breaker that was also listed, you are seeing something around CloudWatch. CloudWatch is a monitoring service on AWS that basically helps you take logs, right? You can actually use the take logs of your application on the infrastructure level, on the app level, to basically log what is happening, right? So if failures happen, you can basically trace it and say, okay, this is where, or this is the blast radius, or this is where the source of this error is coming in from. Another thing that you can do to make your application resilient is something called auto scaling. Now, auto scaling, why do you need to auto scale? Now, let's say your application blows up on the internet. People now like your application and they are using it. What will happen is that your server that you're using has a particular limit, just like you're using a laptop now. There's how you will load it up, load Adobe Premiere, load After Effects, load all this heavy software. What happened? Your system begins to slow down, right? And once your system begins to slow down, you won't have a very good user experience, right? So that is the same thing that happens. For example, when Jumia has Black Friday, everybody's hitting the Jumia servers, right? Since everybody's hitting the Jumia servers, the bandwidth can then be used up very quickly, and then you have the system becoming very slow. You just want to load up one page, one product page or product detail page, and it's taking hours just to load. You see, that kind of experience is not good for the user, right? So what can you do? That is where you do something called auto scaling. Now, auto scaling is a form of mechanism that actually helps you watch the requests, and then you can scale your compute layer based on the requests that are coming in, based on something like CPU utilization, right? How many requests are coming in, how many, for example, let's say you have one server now, and that's your base server that is running at every point in time. More requests comes in that is more than what the server can actually hold. What it's going to do is that it's going to scale up. It's going to scale to basically accommodate more requests. Now, how does it scale? It can bring up a smaller or identical system, right, to basically take care of the spikes, the new requests that it can't take care of, right? And once the bandwidth is now more available, right, the requests are much more lower, it can then scale in back. And once it scales in, that means you don't need that computer anymore. It will just destroy it, and you'll be fine, right? So, but that has to happen automatically. That's why it's called auto scaling, right? And when it comes to scaling, there are different ways you can scale. You can scale horizontally or scale vertically. Scale horizontally just simply means, for example, you have a front-end server or back-end server that is apportioned 2 vCPUs and 4 GB of RAM. Now, to scale it vertically means, oh, this 2 vCPU and 4 GB of RAM is no longer enough. So what you would have to do is maybe take it up to 4 vCPU, and 8 GB. So that with that now you have scaled it vertically. Now, but the example I explained before, where you bring up a smaller compute to basically take care of that request, is scaling horizontally. You're scaling, bringing up more instances to take care of that load. And once it's done, it can then shrink back in, right? So it's advisable that you scale horizontally, because that actually is where auto scaling comes in very easily. To scale vertically, you may need to do some manual work depending on what kind of infrastructure you're running. On AWS, we have something called auto scaling groups, which you can set, and they will take care of your scaling for you. Okay. Now, at this point in time, there are different scenarios here, right? And this is where I'll be moving on to basically the draw.io board. So before I get to these problem statements, let me go to my draw.io board. Please confirm that you can see my screen. I'm actually on a board, a diagramming tool called draw.io. How many of you are familiar with draw.io? If you are familiar with draw.io, okay, Chris, you are familiar with draw.io. Is that Kelechi? I think I will need voices at this point. Are you familiar with draw.io? If you are familiar, just unmute and say, okay, I'm familiar. If you're not familiar, just say you're not familiar.
Yes, I'm familiar with it. Yeah.
Okay. Thank you, Mustafa. Anybody else?
Yes, I'm also familiar.
Okay. Thank you, Faisal. Okay. So now let's take a step back and let's do something really quick. Let's say for that example where I was saying that you upload a picture or you upload a CV and then you want something to be done on that CV. That is basically an event-driven architecture. What would that look like in practice? Now, I'm going to take you to the context of AWS, right? Or let me first do something generic. So you would basically have your storage layer, right? Which a user would basically upload something to. Now, once your user uploads, you would basically need something, an event to be triggered that, hey, we have something new, and then your processor will come in to process whatever requests and give you your outputs. That's simple. So let me just say emit loaded events. So this is just very simple and very direct. Now, how would this look like in, let's say, AWS? Now, it's the same thing, right? So in AWS, we have a storage service called S3. Right? So when a user uploads to S3, S3 has something called their events that it can emit via the event bridge, right? That, oh, you just did a put, you just did an upload into the S3 bucket. Now, for your processor, you could use something called a Lambda. For those that are not familiar with AWS, I'm going to explain everything once I'm done with the architecture. So what's happening here? So your storage layer is S3 buckets, right? This S3 bucket that's what it is. Just store your assets. You can store media, you can store CV, you can store your documents. That's where CV is, your images, right? And it's good to go. And then you have your Lambda, your AWS Lambda. Now, what's happening here is the S3 sends out an event via event bridge that, oh, and input event has happened. And then the Lambda, which is a serverless function, right? So if you just want to run your code without having to bother about servers or provision a server, you can just make use of a Lambda. You just basically specify what environment you want your code to run in, whether it's a Node.js environment, whether it's a Python runtime environment, and then it will just take care of running the code when it is being called, right? Now, once the Lambda is done, it can store it in another S3 bucket. Let's say you wanted to process the CV and then your results, you want to store it in another S3 bucket. So this is your output. So this is one example of an event-driven architecture, right? User puts and a document. Let me see, documents. Right? User uploads a document to S3 bucket. S3 sends out an event and and emits an event and say, okay, something has been put into this particular S3 bucket. The Lambda can then take over and then process the request and then put it back into a different S3 bucket as per finished work. All right. So do we understand this so far?
Yes,
Yes.
it is understandable.
Okay, very good. Now, there is a problem with this architecture. Can anyone tell me what the problem? Anybody that has had experience with, or if you just looking at it, what do you think is the problem with this architecture? I'm angling towards something like resilience now. Anybody?
I think it is a one-way flow. So if whatever happens, it doesn't upload, or at any point it fails at any of the stages, you have to user have to re-upload it again.
Very good. That's one way of looking at it. That's very insightful. One way. There's no way to basically retry, right? There's no way to basically retry and say, okay, something failed for any reason, because you have to expect failures in your systems. Like, failure is part of the process, but how does your system now handle that failure? That is the much more important thing. You understand? So what can we do to basically, first of all,
Also, there is no criteria or anything mentioned, like as you said, upscaling. So in S3, if multiple users will attempt, like here it's example of one, right? So if multiple will attempt, so how we will manage that? I think
yeah,
in that diagram it should be mentioned, right?
okay, that's another perspective to it. Now, there's something that you need to know about Lambda. So Lambdas can spawn. So in a way, it's kind of auto scaling, right? I just didn't mention it. So if you based on the event, a new Lambda can be triggered to basically take care of the requests, right? But that means you are basically spawning to an exponential or an n number of lambdas based on the request, which is not really ideal. Of course, depending on the kind of integration you're doing, lambdas can be reused instead of spawning new ones, right? So one thing that we, as a best practice, one thing you can do is basically introduce queuing, right? So you can have a queue. You can have a queue in between, what's it called? You can have a queue in between the processor and say, okay, let's have a queue that would have that request coming. Do I use SQS now? Let's just use normal diagram. So we can have a queue, right, that will sit in between I don't want to struggle with this guy, not today. Okay, so you can have a queue that sits in between your processor, your storage and processor. Now, what this helps you do is you don't want any of the jobs to be lost for a period of time, right? You want it such that it's available in either a first in, first out approach, where as more items are joining the queue, is being processed, right? And then maybe you want to be able to manage how much, maybe you have a pool of processors, you just want to be able to manage them. So this queue helps you manage it such that you don't want to spawn only, because your compute is not really unlimited. It's actually is a limited resource. So based on that, you can have your queues manage the processor and say, okay, I have something for you, process that request you have. And once more things are joined the queue, it would basically keep them until another processor comes in and picks it up again from the queue and then moves on to the next stage. Now, I'm not saying this is exactly how it's going to be in practice, but the variant of this is having something called SQS, Simple Queue Service. How many of us are familiar with SQS? Is anybody familiar with SQS? Faisal, are you familiar with SQS? Can anyone hear me? I'm not sure I'm even being heard at this point.
Yes, I can hear you.
Okay.
I think same. This is as you said, this is for the scalability, right? And changing the components for independent users, right?
Yes, exactly. So the Lambda itself can actually scale. The Lambda itself can scale, but something can go wrong. The request can be dropped due to any failure, right? But if you have some sort of queue, anybody can just come back and pick up that request, process it, and then do what needs to be done with it and store it. Do you understand? So you still have your inputs. This Lambda will basically take care of put it in a queue, or if there's a way to directly integrate it, you can directly integrate it and then have it on the SQS queue. All right.
Yes, like we can be reliable on this to not lost any request.
Yes, exactly. So we don't lose any of the requests coming in. All right. So that is, at least for now, we've actually built something that is a bit more resilient, right? This is more or less likely to fail than this. Now, let's look at it again. We have event-driven architecture, and then we have resilience built in because of the queuing system. Queuing helps us to be able to manage our compute layer and say, okay, manage these requests. If something goes wrong, somebody else can come back and pick up that request and still process it again. But then again, you need some sort of monitoring, right? You need to know what's going on at every point in time. And that's why we need something called CloudWatch. CloudWatch, right? So CloudWatch can be the monitoring layer that basically monitors the entire thing. As you're flowing from step to step, you can have CloudWatch taking logs of, oh, user uploaded a document. Lambda processes that document. Oh, it's put in a queue, right? And after it's put in a queue, the pre-processing or the post-processing is done, and then it's stored in an S3 bucket, right? So if something goes wrong, like something goes really, really wrong, you'll be able to trace it from your CloudWatch logs. Please confirm if you understand.
This can also automate,
Okay.
right?
Sorry?
This can also automate.
Yes, this can be automated. So you have to basically turn on CloudWatch. So each of these services, they integrate, because they are AWS services, they are all AWS services, they integrate directly with CloudWatch. You just basically need to turn it on for that particular service and have it do what it needs to do. Now, if you need much more custom logs, you can write custom logic in your Lambda and then have it log custom fields and say, okay, request started at this so time, request was processed at so time and finished at so time, right? All of that can be automated. It's basically still code you are writing, but the layer of code is in your lambdas, right? The queue just is already defined. What it does is already very defined. Just store the request as they come in and process it, and let the processor pick it up when it's available. Okay. So do we understand it so far?
Yeah.
Yes.
Awesome.
Awesome. All right. That's nice. What else I want to show if I move on to the next thing? Okay. I think we can start doing the scenarios, the problem statements, right? So let's go through some of these problem statements. We have I tagged the microservice so that you'll be able to basically have a clue into what may solve this. Now, users struggle with slow login times during peak traffic on a social media application, right? I'm just trying to log in, right? Remember now, let's use this situation of Jumia or Amazon, right? Amazon never actually experiences this issue because they are basically using AWS under the hood. But I can use Jumia because we experience this with Jumia even every Black Friday. I'm trying to log in. I'm having issues with login, as simple as login. I just want to log in, right? And guess what? Everybody's using that application at that point in time. So what can solve this? Number one, you first need to ask, is your login service decoupled from the rest of your application? If not, then you would have to, if depending on how much work you want to do, you may need to decouple that login service into its own service or a microservice, so that at least whatever is going on in other services will not affect. At least people should be able to log in to do whatever they need to do, right? That much should be available. Now, then again, you could say, hey, it's not always a microservice thing now. I already said it's systems have capacity. What about if we bring up more capacity, right? Let's say the front-end server or the social media application is running off a server of 2 vCPU, 4 gigs of RAM. Hey, let's just auto-scale it now. Let's bring up another system, right? A smaller instance that can take care of the requests, right? And then have it scale back in. But here's the problem with that. You are scaling every part of the application. That's if it's a monolith now. It's only the login service that needs to scale at this point, right? So what that means is that once the scaling happens, it goes across all the services. Now, if it goes across all the services, that's just waste of compute. Do you understand so far?
Yeah,
Hello?
yeah.
Yeah, so that's just waste of resources. So microservices help us so that we can scale each component independently, right? So if we scale each component independently, let's say it's product listing that is having a very high traffic. What happens is that only product listing will need to scale, right? If it's login service, maybe people are logging in to check their balance or check their wallet, and that's really what's experiencing high traffic. Only that it will need to scale. You understand? Same thing with all these other delays. So same thing with is basically microservice, right? First of all, you need to microservice this application so that at least scale each component independently. Now, look at this other part that has to do with event-driven application. I think we've already touched on this where we say, okay, you want your users to be able to have something done after they upload something, right? So if users are waiting too long for their photo thumbnails after uploading it for a blog platform, you may need to have an event-driven application or architecture implemented there where after uploading, the job kicks off to process the photo. Once you process the photo, the user can then be notified that the job is done, right? You see that in many of the things that we have, right? Where you maybe upload something and it's going to tell you that please wait while it will take a bit of time. Then it tells you that, oh, you can go off the page if you want and come back. So that's basically event-driven. That's what event-driven architecture helps you to do. So this part that has to do with travel application crashing when payment fails. Now, resilience, once that payment system has failed, you basically want a circuit breaker to tell other systems, hey, this guy is no longer available. Maybe you want to retry, check later, right? So at least your users will not experience a disruptive experience. They will not have a bad user experience. It's just that particular service is not available at that point in time. So at least there's a way to manage it. It's better to have, like we say, have bread is better than nothing. At least you can be able to do other things. It's just that particular utility is not available at this point in time. Now, another thing that happens with another problem statement here is that a service slows down the entire, like one service is slowing down the entire e-commerce site. Now, that speaks to one thing, a monolith, right? Because why would one thing be slowing down everything? Now, it may also be that maybe it's not a monolith. Maybe they are all dependencies and they are chained together, right? Now, if they are chained together and they are dependent, if maybe I call login service and after that I want to load my balance, balance service is calling wallet service is calling maybe an external integrator, right? And then you have that dependency. What you also need to do is to have something called timeouts. So if you've waited for a while and the request is not completed, you should basically time out that request and gracefully handle it, right? Ask the user to retry. Then under the hood, you can basically retry the request again, depending on how critical the request was in the first instance. Now, the last one here that says a streaming service lags during high viewer spikes, right? So resilience, one thing that can solve this here is to have scaling in place. So basically taking more requests. Streaming is very compute intensive, right? Very bandwidth intensive. Very, very quickly, memory of your compute could be used up. So what do? You scale up, right? To basically take in more requests, and then you'd have your users experience little to no downtime over time. Do we understand everything I've tried to communicate so far?
Yes.
Okay.
But In last, I think there would be bandwidth bottleneck also, right? Like if the bandwidth have issue, the user's bandwidth.
Okay, so when I say bandwidth, so it's amount of requests the server can take, right? Not the user himself. Do you understand? So each request that comes in for any two servers or any one server, it has a particular amount of requests it can take at a particular time. That is what I mean by bandwidth. You understand? So if it's the user side that is
Yes,
experiencing network latency, right? That's a different thing entirely. But let's say all the users have good network connection, they're hitting the servers, bam, bam, bam. What will quickly happen is, just like when I was saying, you open so many applications on your laptop, what's going to happen is going to slow down, right? They would experience a lot more latency because the bandwidth is already full. It's already it's already at capacity, it's already running at full capacity, right? So the only thing you can do is to bring up more capacity to take care of the spikes that come in. That's the more requests that are coming in from users. Do you understand that now?
yeah, yes, yes.
Okay. Now let us go back to the draw.io board to see some practical. Okay, let me create another page. Now, let me do a scenario, and I think this is where we'll be rounding off so that I don't take more time. But I think we've been able to communicate a thing or two around this. Now, let's say, and this is what happens to many of our startups. We have Faisal here, we have Chris on the call, and let's say after now, Faisal and Chris get together and say, hey, I have this idea. Let us build this application. And let's build this MVP. Now, because it's an MVP, it's okay for it to be a monolith at first. Because here's the thing with microservices, as good as it sounds for it to scale, independently scale and all of that, what's the other side of it is costs, right? If you're using a cloud resource like AWS, the more you scale, the more you spend, right? Depending on what kind of plan you are running on. If you are running on demand, you pay some amount of money each time you scale. Not some amount of money, you pay money each time you scale, right? So in the initial point in time, it may be okay for you to run off a monolith. We're not saying monoliths are bad. That's the way we've been running systems for a while now, before microservices became the in thing, right? So we could have this application, right, run as a monolith, the web app. Let's use a bookstore, application, run as a monolith, right? Let me even enlarge this. Let's say in this application, you have your front end, you have your back end, you have your front end, back end, and your database. This is typically your normal 3-tier application, right? Now, this is running as a monolith on just one server. Okay. So at the MVP stage, this is fine, right? Your users will just basically, make a request, load up your front end, your front end will call your back end, still running on the same server, and everything is fine, right? Everybody goes their own way. But remember, this is MVP, so this is okay for MVP. A pop quiz. Who has a clue into what framework that runs like this, where everything can be coupled together in this kind of, like, you can easily make monoliths. There's this very well popular, a very well-known framework that is very notorious for this kind of thing. Anybody? Anybody?
Could you go specific in language?
Yeah, framework, language. Yeah, go ahead. Like
Next.js.
Next.js, okay. But Next.js is a bit
You
more
could do with
recent.
Django too.
Django,
Django.
okay. Okay. Yeah, I think, yeah, Django too. Next.js, Django. What's that one again? There's one that's very, very notorious. PHP. PHP.
MVC also.
Sorry?
ASP.NET MVC.
ASP.NET.
Yeah, ASP.
Yes. Very, very notorious for such a setup, right?
Yeah. Yes.
Right. But the one I'm actually very, very antagonistic about is the PHP. I'm not saying PHP is bad, though. It's like a lot of multi-million-dollar projects have been done on it, right? But with PHP, it enables you to quickly build monoliths, right? But let's say down the memory line now, a lot more users are hitting this application. There's now need for us to scale. Now, let me write this down here. Let's say at the time of MVP or at the time of launch, we were okay with doing, we're okay with doing 4 VC, no, let's use 2 vCPU. And let's say 4 gigs of RAM. All right, so 4 gigs of RAM and 2 vCPU was okay. Now, as more users are coming on board, you'd say, your application is the best in the market now. So more people will start using your application. Can we see a problem with this current setup? Can we see a problem with this current setup? Can anyone just quickly tell me what is the problem and how can we solve it in the shortest time possible?
I think it's horizontal scaling.
Horizontal scaling.
I mean, yeah, it kind of increasing CPU and stuff. So
Yeah, and
increasing
why
CPU.
why is that the best choice in this case?
Because if you look at trying to decouple the different applications, it take a longer time. So it's best you just scale vertically, like increase CPU.
But if you scale vertically, what is the downside?
I think vertically, I think should be over time. It will not be the best because it becomes expensive, unnecessarily expensive.
Okay, you are right in a fashion, but there's also one other thing that you also need to outline, which means each time you want to scale vertically, you will experience downtime. You have to basically turn off, right? Or the system itself will go offline for a while because it needs to reboot using the new compute that you've actually assigned to it. So for now, because everything is tightly coupled together, you would basically have to scale vertically, right? You basically can only scale vertically. Can I drag this guy? I should be able to drag him. Okay. The only way to scale is vertically. How can I make this guy bigger? Okay. The only way you can scale is vertically. Now, with vertical scaling, what you now then experience is that each time you have to vertically scale, you now have experienced downtime. The system needs to go offline in order for it to reboot. Now, let's re-architect this, right? Let's re-architect this. Oh, supposed to make a duplicate. Now, let's have the individual components run in their own separate container, right? Let's have them run separately, right? Now, can someone tell me, and then a lot of requests are coming in. Can someone tell me how we can scale? How can we scale here?
We can scale horizontally. We can scale horizontally now because they are decoupled. Like you can actually increase the different, either it's backend or your data DB, like scale multiple, have multiple, span multiple server for each.
Exactly, for each of them. So front end can scale independently, back end can scale independently, and then if your database needs to scale, but I don't think this database one has to be a managed cluster. It has to be a managed cluster for your database, right? That's the only other way this can actually
Yeah,
work.
like sharding,
Sharding, exactly, right? But then
Also, we
again,
can use multiple tech stack in this architecture.
okay, so multiple tech stack. Well, I think what you mean by multiple tech stack is maybe front end
Yeah,
would be
I
using
think
like
Yeah, we can use many languages, many frameworks in this architecture style, right?
yeah.
mm,
But in
I
another monolith, we are like locked. Only one
okay,
framework,
okay.
only one language.
Yeah, I think you're right in a fashion, but the flexibility we get here is not, of course, here there's no flexibility, here there's a bit more flexibility, right? You can, instead of using C# or .NET, ASP.NET, C# front end for front end and back end, you can basically have your front end guys work with React or Next.js, back end with Next.js or Node.js, uh, or Django for backend, or Fast API, right? So there's a bit more flexibility. But can we say that this is a microservice architecture? Are we there yet?
No, we are not. We cannot totally say it's a microservice architecture,
Okay, why
basically.
is that? Why is that so?
Because there is a lot of the coupling, like a lot of the coupling you can actually do, like especially from the backend side of things. You can have
Okay,
a kind of authentication service differently. We can
very
have
good.
a user service differently. So we have to decouple the backend service if we want to maintain a high level microservice architecture.
Very good. Very good. So what that means now is the next step is for us to do further decoupling. Right? So what would that look like now? It means that this backend would then be split into a cluster of services that can be called independently. They can call themselves independently. They can talk to each other, and then you can scale. And then I think even with microservice, it gives you ability to even do a more event-driven system because everything is decoupled. You don't need to call in the entire application in order to just get it to do one simple thing, right? You can just call the service, right? Of listing payments, right? All of these as independent services, right? Now, Faisal said something around using different languages. I think here even gives you more flexibility. You can, although for whatever reason, though, you can, I think the thing that you would say here is you can use the best language or best framework for that particular use case, right? So auth can be written in Fast API, can be written in ASP.NET. Listing, product listing can be written in Fast API or can be written in Node.js. Payment system can be written in ASP.NET, right? You have more flexibility here, right? Do we understand so far?
Yes, yes.
Okay. I'm glad I was able to give value. So let me just architect. Let me just complete this here. And all of them can then talk to the database. Right? So I think this is a truly microservice architecture. Right? I think everyone can agree that this is far, far better. But then again, I would say something around downsides. For this one, the downside was okay. The positive side is that at least you can use different languages. Let me bring that out. Let me just outline it. As for benefits, we can use different. Let me make this bigger. 15. You can use different. So there's no limit. I think we're not restricted. No restriction. Restriction on stack, right? So front-end systems can be built differently, back-end systems can be built differently, right? But then again, it's still not microservice yet. Here, you have, okay, now that we have a fully microservice system, can somebody tell me one of the downsides here? What are the downsides? I think I've even mentioned it already. What are the downsides or things or the gotchas you need to watch out for a kind of system like this? Anybody?
Basically, I think you mentioned it before. I think it's one of the services. Like if one of the services is down, it can automatically affect other services. I think that's
For
what.
you mean for microservice or for monolith? Which one?
For microservice, like for one of the downside, like let's say the hot services is down, automatically you cannot actually make movements.
So here's the thing around that. Depending on how well you implemented so if you implemented your microservices properly, that should not happen. Of course, auth is a very critical service. Without it, no other thing can work. But let's say product listing goes down, right? Let's say we have more services here, right? Product listing, recommendation, what else? What else? Summary engine, something like that. If any of them goes down, ideally, no other service should be impacted. The blast radius should only be for that particular service. You understand? That's what should happen. So if you implement it properly, that should not happen. Now, but what the downside I was expecting to hear though was cost of compute. Now remember now that you can then scale each component independently, right? Before, we couldn't scale at all. The only way we could scale was vertically. Now we could scale the front end, back end, and DB independently. But for the back end, that means we are scaling for all the service. That means we are wasting compute. But here now, each service can scale independently, right? But there's something we need to watch out for, which is cost, right? And that's for, I don't know why, but developers are not always concerned about cost when it comes to cloud services. Remember that we're in the context of AWS as much as possible, right? And a lot of people will say AWS is really expensive. It's basically how you use it that makes it expensive. AWS gives you the opportunity for you to pick. So there are multiple ways to actually deploy a particular service. Is now how you deploy is dependent on how much control you want. Do you want scaling? And scaling by how much? What's the manner of scaling? You understand? So you need to basically do a cost analysis on your architecture and say, what is the cost impact of going with this architecture? I say this because there are times I've had to even scale down architectures for customers because it was obvious that by the time I did the pricing for it, because that's part of what I do, after you've done the architecture, you need to tell them where the money is going. You need to explain the money trail, right? By the time they see the money trail, they're like, I don't think we can support this. And that is why I said for small MVPs, a monolith is fine, right? Because you just need just one compute, you run it, your users do their requests, boom, bam, you're done, right? Here, it's also still fair. The amount of cost you spend here for like an optimally running system, this is the cheapest to run. This one is slightly more expensive. Microservice is the most expensive, right? Because these guys would scale independently, and with a lot of scaling going on, your money could just be going different areas. That's why monitoring, number one, is very key. You need to have monitoring in place, even for all of them. Like monitoring is a core thing of application. Then again, you need to basically have a way to manage your infrastructure. And that brings us to something which is not in my slide at all, called tiering, right? It's a concept where what is your most important application must not go down. Like users should be able to log in at any point in time. So we put it on tier 1, right? So those ones will give it a weight of, maybe we have a weighting system and say, okay, from 5 to 1, we'll give it a weight of 5 because it must be on no matter what. Listing. Well, listing is very, very important, right? But not as important as auth. We give it a weight of 4 or 3. Payment is very important, as maybe on the same level as listing, we give it a point of 3. Maybe the recommendation, you know how you go to all of these shopping sites and they recommend other products to you. If that does not appear, users will be impacted, but not as much as if auth or listing or payment is down. So we give it a weight of 2. Please confirm you understand what I'm communicating up until this point.
Yes, understood. But I have one concern. Like we are connecting authentication, listing, and payments all to one DB. I think this would be a single point of failure, or no? Like the DB should be separate for all of them. If all the components are accessing one DB, the load will be on one DB, like performance degrade or low performance, right?
I think you're correct in that regard. I think what I did not do was state that this is a cluster, right?
Okay.
So this should be a cluster. It's a DB cluster. So it has multiple servers. That is a managed environment, right? So depending on, yes, each of them can have their own records, right? But you basically would want to, for example, if users are authenticating, you need access to their user records, right? If you are listing products, the listing product may or may not need access to user records, right? Payments may or may not need access to user records, but it would definitely need access to payment records. Listing would need access to listing records. So depending on, because even the database architecture is even another thing entirely, right? We have professionals that all they're dedicated to doing is architecting your database layer, right? That's why I just even abstracted it there, because if we get into it, you will see that you have to, depend on your as need basis, you can even decouple your database layer and say, okay, authentication for users have their own database. But then again, you have a problem of how do you do propagation and replication across. Maybe there's a particular record, a user bought an item, and you need to store the IDs in multiple records. You need something that will propagate it across all multiple records, right? That's why the simplest approach is just have a DP cluster that manages all your records and that can scale as per needs basis.
Yes, got it.
Okay.
Thank you.
Yeah, thank you. All right. So I was explaining tiering. Any other person understand what I was saying about the tiering? First tier, giving it a weight of 5, giving it a weight of 4, of 3, and 1. Anybody? Or do I need to take over that part again? Hello? My guy still here?
I understand. We understand. I understand.
Okay. Okay, noted. So now that tiering helps you to assign scaling capacity based on needs basis. Auth should scale like very well. Listing and payments should scale, but not as much as auth. The recommendation and just scale a bit, right? Don't be right. It gives us a way to assign compute or capacity based on importance, right? So again, let me just go about it or go over it again. When you're running a microservice architecture, one of the things you need to look out for is costs, right? Especially when you're running a cloud service, you have to look out for costs. They need to have monitoring in place, right? Have monitoring in place, right? You need to be monitoring the system always, right? Then there should be graceful handling of errors. Then there should be timeouts for requests and dependencies. Then, which other thing again am I forgetting? Graceful handling of errors, timeouts, retry, right? Retry with backup. So this retry with backup is that something you tried, a service was called, it failed, right? Or it timed out. You wait 3 seconds, you try it again, or you wait 30 seconds, you try it again, right? It's failed again. Instead of waiting another 30 seconds, you wait 1 minute this time. So that's backup period. You wait 1 minute and you try again, right? You keep increasing the wait time until you tell it like, oh, the maximum retrial times is just 5. Once you try 5 times, you cannot go. Just gracefully handle it and say, this service is not available. Open the circuits, right? Circuit breaker as well. Did we understand so far?
So, I'll ask a question. The circuit
Yeah.
breaker, is it for monitoring services that is done, or
So
we focus that on monitoring? Like, I don't know if you get what I'm saying.
so
When a particular service is done.
okay, so let me explain this way. Monitoring or your monitor, your logging system is basically passive. Circuit breaker is active. How do I mean? I have service A. Let me zoom in here. Service A that is making a call through the circuit breaker to a service B. You understand? So the circuit breaker is basically reacting. If service A tried to call service B, and for any reason there is an issue with service B, it would open the circuit, right? It will be open. Right? So what this helps to do is service A will not have to keep on calling service B, right? So the retry and circuit breaker can work hand in hand here, where you try to call service B, it's timed out or there was an error the first time. You do a back of 30 seconds or 4 seconds. You try again. an error still occurred. Okay. Then we try again after 10 seconds. Same error. We try again after 15 seconds, then 30 seconds. After that, the circuit breaker can then react and just say, you know what, stop calling the service, just open the circuit, right? Each time the service A tries consult the circuit breaker, it just tell you it's not available, right? So the circuit is open. So you don't need to keep on calling this service and waiting for it to return back to you. Because remember that when you call an API, you are basically waiting for that API to return a response to you, right? So if that API fails fast, it means that you don't have to spend all that compute and bandwidth waiting for a request to come back. And we already know that the service is down. Do you understand the difference between the monitor and the circuit breaker now? Hello?
Yeah, for me, I understand, but I think I'm just thinking about like what exactly, like in kind of real life application, what exactly, how like circuit breaker, if it's like a code or a logic, like how does it look like? Or if it's a tools that we can use, like how does it look like? That is what I think like my question, if I have a question to ask.
Okay,
I don't
so
know if you
for
get what
many
I'm
of
saying.
yes, I understand what you mean. So for many of these systems, there are SDKs, there are tools that you can use. What's it called? Depending on the stack, right? You can, if you are a Node.js, if you are a Next.js developer, you can check up. I'm sure there are many SDKs that you can actually check on how to implement circuit breaker system on your backend. Now, an application of this is, let's say you have a payment integrator, Paystack, right? Paystack helps you make your payments on your platform, right? So it's a dependency. You don't manage Paystack. You don't have any insight into how Paystack, the compute or their engine or how they are basically scaling. All you just do is call the service. You understand? Now, if the first time you call the service, the Paystack service, it failed, right? Okay, you just wait again and say, okay, let's try again. You retry. It failed again. You try the third time. The second week I can just kick in and say, you know what? I think Paystack is down. So we are not going to call Paystack again. And that leads me to the next point where for any dependency, they'll tell you that have alternatives, right? For example, maybe Paystack is down. Have your guys use maybe USSD. Have them use maybe Flutter Wave or Remita or any of these other payment processors. What will happen is that you will not have total breakdown of service. You maybe Paystack was the best choice, right? But your best choice is not available. It doesn't mean that users can't transact. It just means that they will just need to choose a different option to be able to do that business objective, which they would have easily done with Paystack. Do you understand where I'm driving at here? So for the
Yeah,
first, yeah,
yeah, I
so
understand.
you
So
would
you
need
can
to
just use something like a feature flag to turn it down, like and
exactly that.
turn the
Oh,
other service, the other options up.
yeah, exactly that. Oh, it's not available. So just take it off. Right? So use the ones that are available. Use Remita, use the other payment platforms, right? So this will just help to manage your users and just say, you know what? In fact, you will see it in many of these payment applications. 1 minute you are seeing the guy that you normally use to make payments, and all of a sudden you're not seeing it. You're wondering, what happened? Which update did they do? Like you said, they feature flag it and just say, let's take off this guy. It's not available at this point in time. And one very, very obvious use case for us in Nigeria here is if you use all these VTU applications, right? VTU applications, you want to buy data. MTN, these VTU applications integrate with these other telcos, MTN, Airtel, Glo, right? MTN may be up, but Glo is down, right? So what some people will just do is to gray it out. In fact, that's the perfect option. I've seen that. That's the perfect example. I've seen that happen many times. They'll tell you, "Oh, MTN is not available now." It doesn't mean I can't still buy data. It just means that probably that my Airtel SIM that I kept one place, I will just need to basically use that until MTN is back. So the platform will still make money, maybe not as much as they would have made if MTN was on, but there's no total loss of service. Do you understand all these concepts so far?
Yeah, I understand. For
Okay.
me, I understand.
All right. So at this point, I think I think we'll stop here.
So I have a question. I have a
Yeah,
question.
please
Now, I
go on.
think when we are using a microservice, like you have to
Mm-hmm.
couple them in the kind of a central application, right? Like using API gateway to
Mm,
who's I don't know. I'm just like asking. So basically, I think I would like to have some kind of this thing understanding that on that side, like when you bring everything together, they are all microservice. So, but we have to bring them together, right?
mm-hmm. So
So,
when you
like,
mean bring them together, so you can have something called, you can have a router that will route based on
yes,
certain
yes,
things, right? Your
yes,
API
that's what I
gateway, like
mean.
you mentioned,
Yeah.
you can have,
So, do you need to also scale? Is there a need for a kind of decision to also scale that kind of application that is handling the router or the router application itself?
so when it comes to directing traffic, you would need to make use of something called a load balancer, right? A load balancer would basically distribute load or route traffic to that particular request. I think one example of this is if you are running an NGX NGX backed infrastructure. NGX is going to be the load balancer there. It works on top of your actual server or compute there, right? So API gate, if you are using like a service on AWS like API gateway is self-managed, right? Let me just maybe let me draft this quickly. Users, right? They're calling API gateway. So you can actually have your load balancer scale as well. But if you're using API, if you're using AWS and you're using API gateway service, the API gateway is self-managed by AWS, and they take care of the scaling that needs to be done per request. Do you understand? Hello, are you there?
Just go on. I'm listening.
Right.
Okay.
Where's this thing?
Okay, so
Are we out of time?
um, not really, but
Okay.
obviously we need to wrap up.
Yeah, definitely.
Do
Definitely.
you guys
Okay.
have more questions for Christian? If you have more questions, please drop in the chat. Otherwise, we'll have to continue in the community. If you have more questions on this, if you're not in part of the community yet, I'm going to be dropping a link so that you can join. So you'll be able to ask your questions. Christian is in the community, so you can ask him as much as you want. Hope everyone is enjoying the lab. Hope you guys have
So,
learned a lot today.
Kristen, sorry. You can also provide like your kind of name your name or like username, I don't know, or
Okay, give
display
me my
name on the
contact.
yeah,
On
like
LinkedIn,
on the
okay,
platform, or
Chris,
possibly on LinkedIn, no problem. On LinkedIn, no problem. Or but a kind of way to reach out, like you understand.
Okay.
Uh,
So my name is my name on LinkedIn, Christian Oyisi. Let me just type it out. And of course, the blessing would send out a message on the channel as well. So tagging me. So you can reach out to me.
yeah. Okay, so thank you so much, Christian. That was an amazing session that we just had. So I'm very sure everyone have learned a lot of things from you. And I want to say thank you for we are actually happy to have you here today.
Thank
So
you.
it's networking time, guys. It's networking time. Christian, you can stop sharing your screen now.
Okay. Thank
So it's
you.
networking time. So if you have if you would like to network with each other, please drop your link in the chat. Drop your LinkedIn profile in the chat so we can network together, get to know each other. Let's do that quick.